In this video, we are going to explore the internal object storage system of Git. We will learn about how Git organizes and stores data. Let's begin our journey into Git Internals, focusing on the objects that form the foundation of its version control system. Git operates as a content-addressable file system. All the data is stored as objects inside the .git/objects directory. There are four primary types of objects: blobs, trees, commits, and tags. Each object is uniquely identified by its secure hash algorithm 1#, also known as SHA-1#. A blob, which stands for binary large object, stores the actual content of a file. Blobs are content-addressable, meaning they are identified by their secure hash algorithm, 1# of their content. Git stores only the file content, not the file name or permissions within the blob. If different commits have identical file content, they will share the same blob object. To create a blob object from content, you can use the command echo hello git pipe git hashobject-w-stin. This command creates a blob and outputs its secure hash algorithm 1#. To view the blob's content, use the command git cat-file-p followed by the secure hash algorithm 1#. The output will be the content, hello git. To check the object type, use the command git cat-file-t followed by the secure hash algorithm 1#. This command will output blob. Blob objects are stored within the .git/objects directory. The first two characters of the secure hash algorithm 1# are used as the subdirectory name, and the remaining characters are used as the file name within that subdirectory. For example, the blob with secure hash algorithm 1# AF5626B4A114 AP2D6 3DB7-082RES4756051B would be stored in the file git/objects/AF/5626B4A114 AP82D6 3DB7-082-4756051B. The content of the blob is compressed using zlib. The format of a blob is blob followed by a null character, followed by the content length, another null character, and finally the content itself. A tree object represents a directory in Git. Trees store the file modes, which are the permissions, the object types, which can be a blob or another tree, the secure hash algorithm 1 object references, and the file names. Trees create a hierarchical structure, linking to blobs, which represent files, and other trees, which represent subdirectories. To create a tree from the index, first add a file using the command git add file.txt, then use the command git write-tree. This command outputs the secure hash algorithm 1# of the newly created tree. To view the content of a tree, use the command git cat-file-p followed by the secure hash algorithm 1# of the tree. To check the object type, use the command git cat-file-t followed by the secure hash algorithm 1# of the tree, which will output tree. Here's an example of how trees organize a project's file hierarchy. The root tree contains entries for the top-level files and directories. Each subdirectory is represented by another tree object. The files within those directories are represented by blob objects. The root tree's content will point to a blob for a file named readme.md, and to another tree representing the source directory. The source tree would then contain blob objects for main.c and utils.c. The file modes indicate the type of file, with 10644 representing a regular file, 10755 representing an executable file, 040,000 representing a directory, and 120,000 representing a symbolic link. A commit object represents a specific version of your project. It stores a reference to a tree which represents the snapshot of the project, the parent commit or commits references, the author information including name, email, and date, the committer information, and the commit message. Commits form a directed acyclic graph, or DAG, that represents your project's history. To create a commit, you can manually create a commit object using the command echo Tree 7B20E54C9933590C218DD2A0D0D1A6C49C2C parent 9C68D9D4B70A0A6 347C9EB31F9C4B6 If5F70CC author John Doe less than John at example.com greater than 163387 2000-0400 committer John Doe less than John at example.com greater than 163387 2000-0400 add readme file pipe git hash object-t commit-w-stin. To view the commit object, you can then use the command git cat-file-p followed by the secure hash algorithm 1 hash. Commits are organized into a directed acyclic graph, showing the history of your project. Each commit points to its parent or parents tracing back to the initial commit. Examining the commit history can be done using the command git log --1 line. This shows a concise log of commits. To visualize the relationships between commits, use the command git log --graph --1 line. This displays a graph of the commit history, illustrating branches and merges. A tag object creates a permanent reference to a specific commit. Tags store the object reference, usually a commit, the object type, usually commit, the tag name, the tagger information including name, email and date, and an optional message. There are two types of tags, lightweight and annotated. Lightweight tags are simply a reference to a commit, whereas annotated tags are full tag objects with metadata. To create an annotated tag, use the command git tag-a version 1.0-m, version 1.0 release. This creates a tag named version 1.0. To view the tag object, use the command git cat-file-p followed by version 1.0. To create a lightweight tag, use the command git tag version 1.0-beta. A lightweight tag is just a reference, so using git show on a lightweight tag will simply show the commit it points to. Let's summarize the different Git object types. A blob stores file content without any metadata. Multiple files with identical content share the same blob. To create a blob, use the command git #object-w file.txt. A tree represents directories and file hierarchies, containing pointers to blobs and other trees with metadata. To create a tree, use the command git write-tree. A commit points to a tree snapshot along with author and committer information, timestamp, message, and parent commits. To create a commit, use the command git commit-tree less than tree secure hash algorithm greater than -p less than parent secure hash algorithm greater than. A tag creates a permanent reference to a specific object, usually a commit, with optional metadata. To create a tag, use the command git tag-a less than name greater than commit secure hash algorithm greater than. All Git objects are content addressable via secure hash algorithm 1 hashes and are stored in .git/objects. Together, they form a complete, immutable history of your project's file system. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.